Hello everyone, this is Alice Gao. In this video, I'm going to introduce you to the area of machine learning. Before I talk about what is machine learning, I want to give you some examples, some applications of machine learning. So machine learning has been hugely successful in recent years. You may already know many applications of machine learning. I have a few examples here, and this list is far from complete. So image recognition is one of the first areas where machine learning made a breakthrough. This allows us to easily automatically label images. So that's how you can search for images on Google these days. It even allows us to perform medical diagnosis. If we have MRI, X-ray, CT images, we can let programs analyze them and suggest some examples that requires human attention. Our smartphones now have facial recognitions where we can use our face as a form of ID. So image recognition, one area where machine learning has been very successful. Machine learning has also been successful in transcribing text. This allows us to digitize old books easily, automatically recognizing handwritten postal codes. One of the first motivations for image recognition is that the US Postal Service desperately need to be able to sort through mails easily, so they need to be able to read people's handwritten digits. So this motivated researchers to come up with good machine learning algorithm to recognize handwritten digits. Speech recognition is another area where machine learning has been very successful. Now we can talk to all sorts of electronic devices at home. We can talk to Siri, Alexa, Google, you name it, your house, your car, and so on and so forth. Finally, there are a lot of intelligent agents that are trying to learn about our behavior and then also trying to do things for us. One example is we already take this for granted. We have software that help us filter spam emails. We even have software which makes suggestions for us when we're writing emails, right? This is just one example where intelligent agents are trying to help to make our lives better. So this list is far from complete. I would be curious if you have time to go do some research and figure out and tell me about what is one application of machine learning that you're most excited about. Let me talk about the definition of learning. There are many ways to define what learning is. Here's one definition. Learning is the ability of an agent to improve its performance on future tasks based on experience. Here are some keywords. We want to improve the performance of the agent, so we are going to need some criteria, some measure to measure the performance of the agent. We want to improve the performance on future tasks, right? Because we are probably using what we know about past tasks to determine how we're going to complete future tasks. And we can do this based on experience. So we need to have some data. We need to have seen some things, and these things will help us to learn about how to complete these tasks so that we can do them well in the future. In other words, the agent needs to remember the past in a way that is useful for the future. So when we talk about improving performance, there are many ways that we can accomplish this. For example, we may want an agent to improve by being able to do more things. This means expand the range of behaviors of the agent. We may want the agent to be able to do things better. So in other words, improve the accuracy on some tasks. Finally, an agent can improve by doing things faster, so improve their speed when they complete a certain task. Now that I gave you a high-level idea of what learning is, you might still have one question. You might be wondering, why would we want an agent to learn in the first place? If we have a task to complete, why don't we just write a program to perform the task? Then we're done. There are several reasons why we might want an agent to learn. First of all, there are many problems, there are many situations we might encounter in the world. An agent cannot and possibly anticipate all possible situations. Even if an agent has seen many different kinds of problems and is able to solve all of them, these problems may change over time. And in general, things change over time, so this is another change where the agent might not be able to anticipate. Finally, when we encounter difficult problems, sometimes we have no idea how to program a solution. A good example is image recognition. We all know that humans have this innate ability to easily recognize objects in images, but it took researchers many, many years to figure out how to do this with an algorithm. So this is an example where without learning, we would get nowhere because we don't understand how our brains can easily recognize objects in images. So these are 3 reasons where we might want an agent to be able to learn rather than us writing a program to solve the problem. Let me talk about the components of any learning problem. First of all, we have a problem and/or a task. This is the behavior or the task that we're trying to improve our performance on. Next, we have some experience or some data. These are the experiences that we're using to improve our performance on the task. This is typically comes in the form of a sequence of examples. Third, we often have some background knowledge, and this background knowledge is going to bias our agent. The agent is going to make some assumptions about the world and even make some assumptions about this task. Now, you might think that such a bias is not right. We should not have a bias, but you will see later on that having a bias is necessary for us to solve certain problems. Finally, we need a measure of improvement. This is trying to answer the question, if we want to know that our performance is improved, how do we measure it? What kind of things do we want to measure? Do we want to measure whether our accuracy in prediction has increased? Do you want to measure whether we have acquired new skills? Or do you want to measure whether we can do something faster, so our speed at solving a particular task? We can divide all of the learning problems into 3 broad categories: supervised learning, unsupervised learning, and reinforcement learning. Now for supervised learning, we're often given a set of training examples, and each example contains 2 types of information. The first type is the values for some input features, and then the second types are values for some target features. So given these training examples, we want to predict the value of the target features for new examples, for examples we have not seen given their values on the input features. So one important point here is that for all the training examples we have, we are given the values of both the input and target features. To contrast this with unsupervised learning, for unsupervised learning, we also have a bunch of examples. You can think about these as training examples, but the difference is that for these examples, we are given the values of the input features, but we are not given the values of the target features. So another way of thinking about unsupervised learning is that we're given a bunch of data and we don't have the labels. Sometimes we think about the target features as labels for the data. So if we don't have the labels, then we're simply looking at these data and trying to make some sense out of it. Usually the algorithms are trying to find some structures in the data. So some examples of unsupervised learning are clustering. If you're given a bunch of data points, can you divide them into natural clusters so that each cluster of data points are similar to each other somehow? Or another example of unsupervised learning is dimensionality reduction. So sometimes if we have data that's really high dimensional, it's very difficult to understand and make sense of the data. So we can try to project the high dimensional data into a lower dimensional space. So that's another example of unsupervised learning. Finally, we have the third type of learning problems, which is called reinforcement learning. You can think about reinforcement learning as somewhere in between supervised learning and unsupervised learning. So for unsupervised learning, we get no feedback at all. We just have data and we're trying to make sense of it. Whereas supervised learning, we get all the feedback that we need, right? For each data, we have the exact label. For each training data, we have the exact label that we need. Reinforcement learning is somewhere in between. We get some form of feedback, but these feedback are not directly telling us, are we doing something right or are we doing something wrong? Instead, these feedback are in the form of rewards and punishments. And sometimes we don't receive these feedbacks right away. We have to perform a bunch of actions and then observe some feedback. And based on that feedback, we're going to decide on what to do in the future. In this course, I'm going to focus on talking about supervised learning and reinforcement learning. For supervised learning, I'm going to cover decision trees and artificial neural networks. I just talked about the three types of learning problems. Let's practice what we just learned. This is a question which asks you to differentiate supervised and unsupervised learning. Here's a story. Given the problem described in the story, is this a supervised or unsupervised learning problem? Pause the video, take some time to look at the question and think about it yourself, and then keep watching for the answer. Here's the answer. This problem is an unsupervised learning problem. Here's why. Let's look at this problem. We have some credit card transactions, and we want to decide on whether some of these transactions are fraudulent or not. And so how does this correspond to the setting of the problem that we talked about earlier? Well, the credit card transactions are the examples we have, right? And in particular, the credit card transaction details, we may know different things about these transactions. These information are the input features for our training examples. Now, we want to decide on whether these transactions are fraudulent or not. So whether a transaction is fraudulent or not is the label or the target feature that we're trying to determine. Now, the last sentence actually gives us the most critical information. It says we have no information on whether any particular transaction is fraudulent or not. This means we're given a bunch of transactions, but we're not given the value of the target features for these transactions. Right? In that case, this is an unsupervised learning problem where we're given data, we're given values of input features, we're not given values of target features, and we're just trying to make some sense out of it, to figure out some structure, to, in this case, to try to see if some transactions are different from others. If they're special, they are likely to be fraudulent. In this unit, I'm going to focus on talking about supervised learning problems. And supervised learning problems can be divided into two broad categories: classification and regression. The main difference between the two are, what do the target features look like? If the target features are discrete values, then they're classification. If the target features are continuous values, then they are regression. So here's a simple example. Suppose we're thinking about predicting the weather of tomorrow. if the target features we're predicting are things like, is it going to be sunny, cloudy, or rainy tomorrow? So these are values for the target features. These are discrete values. In this case, we have a classification problem. Or, in other words, we could be trying to predict tomorrow's temperatures. And although you could argue that temperature is technically also discrete depending on what unit you're thinking about, but usually we treat this kind of numeric information as continuous value. So in this case, we would likely treat this problem as a regression problem. Let's now look at two practice questions on distinguishing classification and regression. The first one, you have historical data on weather condition on a particular day of the year. You want to predict the weather condition of this day next year. Is this classification or regression? Think about it for a moment and then keep watching. The answer is that this is a classification problem. This example is almost identical to the example I gave on the previous slide. We are trying to predict the weather conditions, and the values of the target features are discrete, things like sunny, cloudy, rainy, or snowy. So the historical data are the training examples. For the historical data, we have the day, which is the value of the input feature, maybe other things we know about the day, and then the weather condition, one of these four values will be the value of the target feature. And then we want to predict the weather condition of this day next year. So we're given a future date, which is given the input value of input features for a future date, and then we're trying to predict the value of the target feature. Question number 2. You're given historical data on the price of a house at several points in time in the past. You want to predict the price of this house next month. Is this classification or regression? The answer here is regression. We are dealing with the price of a house, and the price value, although you might think about it as a discrete value because we could only go down into cents, but usually we treat this kind of numeric value as a continuous value. So if we're dealing with a continuous target features, then this is a regression problem. Let me summarize. After watching this video, you should be able to do the following. Describe an application of machine learning that you're excited about. Define learning at a high level. Explain why we want an agent to learn rather than directly programming a solution. Describe components of a learning problem. Determine whether a given problem is supervised or unsupervised learning problem. Determine whether a supervised learning problem is classification or regression. Thank you for watching. I will see you in the next video. Bye for now.